it's like another it's gonna take another 2-3 hours. Okay, so it's not, we are not going to do that. We are going to till here. Okay, deployment you can do using Flask API. You can make your own home page using HTML, CSS kind of thing. Okay, yeah, recording start. Okay, so you can make your own home page kind HTML, CSS, JavaScript. You can make using that. Okay, so deployment, and you can connect that your Python code to that website using various APIs like Flask API, Django. Okay, Django, Django. So you can connect. So basically, I use Flask API. Okay, REST API we say. Okay, so that's what we call end to end. Okay, so here you go. First of all, we collect the data. The collection of data is done by data mining engineer. Okay, and it's the scope of this engineer is very high in the future. Okay, so if you want to become, if you don't want to become data science engineer, data analyst engineer, okay, data feature engineer, if you don't want to become anything, if you just, but still you want to go into a field of data science, then you can go in the first step, data mining. how we are knowing how we are knowing that in this world right now this much cases are there. Someone is mining the data na, from hospitals, or someone is taking the data, someone is collecting the data na. Okay, so that's the role of. Then after mining the data, okay, we do data preparing. See, we predicted the future, right? How many cases gonna happen in future? Okay, but sometimes data is very bad, null values, no values, okay, or blank values, garbage values. Okay, so we need to see missing values handling. We need to do this. We are not going to do much thing. Okay, we are, because time is very less, no, that's why, as I said, this is a head start training. Okay, uh to give you an idea, and it's like a jump start. Okay, now, okay, you just made 2-3 projects and you just got good amount of knowledge. Oops, sorry. uh, okay, so so okay, so from here, after taking the data, we do feature selection, means which of the features are very useful, and others we remove it. Okay, means which of the features are useful for the prediction. Of course, we do feature means the data, which are the data, like, see, today I'm going to make you work in, I'm going to teach you in this. Okay, like, today we are going to do one project called heart disease prediction. See, in this we are going to do one project. Basically, this is the features columns. The columns we called of features. Okay, means column is equals to features, you can say. Okay, in the data science field, the columns we call it as a feature. These are the features, and these are the target variable. This is the target, or y. These are the x, this is the x, this is the y. This is called independent variable. Also, this is called dependent. Of course, this dependent is dependent on all these factors. See, if your age is this, gender, one means male, chest pain, resting blood pressure, and there are many things, then chances are that you are having heart disease. One means heart disease. And then if you go down, 0 means if you come into this range, then you don't have heart disease. Okay, so only we have only 1 and 0 in the target. Okay, either you have heart disease or not. So how to do this? As I said, now in the medical field, AI gonna play a huge role. Okay, so see, this is the most basic project, and the data is very cleaned one. Okay, as time is less now, so I'm just gonna prepare I have the full cleaned data, no garbage value, no missing value. Okay, otherwise if you want to see the missing value, how do they look? Basically, they don't even, you can't even see them because they are missing. But COVID-19, not this one, there you go, which I have uploaded in my channel. Okay, I'll give you the link, so you can predict the future number of cases. See, COVID-19 data. Okay, how do you look like, see, if you see in the state, this is state, okay, this is state. So here you will see no values. So that's we need to handle. Either we can remove full rows, either we can input some data here. There are various techniques. Okay, that's why we say missing values handling. Okay, this is another very important factor. Outlier is another thing. Feature selection. Okay, see, in this heart disease, what are the features which is the most important to predict a person is having heart disease or not? Does age is a very important factor. Common sense, if you apply common sense, yes. Okay, because of course, a 10-year-old kid will not get heart disease or heart attack basically. Okay. Gender, might. Chest pain, yes. Okay, might. Or cholesterol, we can just use common sense. Otherwise, you can use machine learning model also. Okay. So see, data manipulation, there are various things in the data preparing. That's what we call data pre-processing. Okay, data pre-processing we say. Okay, normalizing, I'll tell you. Okay, we will do normalizing. There is called one hot encoding, normalizing. There are many things we do. Okay, then after preparing the full data, okay, like we can't give model, garbage value or missing values or bad values or unnormalized, mean non-normalized data we can't give model directly. Okay, so that's why we need to prepare a good amount of cleaned data. Okay, then only our model will predict, then only predict with good accuracy, otherwise it will not predict with good accuracy. Okay, then model training will done. Okay, there are many techniques. Okay, like many algorithm, either you can apply machine learning algorithms or you can apply deep learning also. Okay, it depends on the data. Model optimization to increase the accuracy. Okay, to increase the accuracy. Then model evolution, of course, how good your model performed, accuracy and all. Okay, based on this, see here the arrows. Based on this, if your model didn't perform well, you can do again model optimization. If it's still not performing well, if it's still showing less accuracy, then you can directly go here for the data pre-processing. Means you have garbage value, you might have missing values, you might have outliers. Okay, you might have selected those feature which is not important. Okay, so then again you need to do. Okay, so that's why data science project takes good amount of time, like a month also. Okay, if you're going in an industry level project, then if your accuracy is good, yeah, if your accuracy, then you deploy it. Deploy it means, in the website. Okay, so deploy it in the website. So you can make a website, and if somebody enters the details, okay, if somebody enters the details, like uh, if their age is this, gender, chest pain is this, then your website will give the output that you might have heart disease or you don't. That's all. That's the whole data science process. Nothing more, nothing less. How many people understood? Let me know. Okay. Any question, then ask me. You can unmute yourself or you can write in the chat. And write everyone. Okay, write everyone. Okay. Okay, understood. No. Okay. So, any question? If anyone you have, then you can just unmute yourself. Okay. Um. Okay then. So see, just go here. Type here to search. Either you can open the Anaconda Navigator. In that you can open Jupyter, or you can directly open Jupyter from here. Just write JUP. If you have installed Anaconda, you will get Jupyter. Okay. So click on Jupyter Notebook. A server will open. This server is needed. Okay, if you close this server, your notebook will not work. Okay, so you need to start it again, because this Jupyter works online. Okay, basically that's why localhost. Just click on new. Okay, and Python 3 you will get. You will get text file also. You can upload the folders or you can get the folders. You can open the terminal also, but we need Python 3. Here you go, Python 3. Let me know when you are done till here. I'm teaching you head start training. So you can just directly, now you can start many projects. Okay, because I'm gonna teach you. I just taught you the process of data science. Now I'm gonna show you where you can get data basically. Either you can mine it, but of course you don't want to mine it. Okay, so for most of the projects, so what you gonna do? Done, na? Huh? So another thing in the head start training is where you will get the data. Anyone having idea from where we can get data, like any popular website if you know? Kaggle, Reddit. Okay, Reddit I have not used much. Kaggle is best. Okay, any more Kaggle apart from Kaggle? Government websites are there. Okay, like GUC or GOVA, something like that. But Kaggle is the most popular. Okay, so see Kaggle, just like Kaggle. Okay, Kaggle you can Kaggle you will find many good data. Okay, and they conduct many competitions. Okay, see, COVID-19, dog versus cats. Okay, and humpback well identification means this competition is going on. Okay, from no competition is going on. I think. Okay, the prize money is $25. Dollars, not rupees. Dollars. Okay. Can you identify a whale by its tail? Just by its tail. Okay, there are various kind of whales. Okay, various kind of whales. So if you just see data, okay, see there are various new whale and how many types of whales are there. Okay, so this is a train. This is the photos. You will get the photos. Okay, it is not opened right now. So you just need to download. You just need to like take the part in the competition, which it will not cost you a single rupee. Just your email address and download all. Okay. So here just search heart disease or see I have liver tumor. Okay, but we don't need this right now. So just write heart disease, heart disease. Okay, heart disease. Or this is one like most of data set are same for heart disease. Okay, go for this heart disease UCI. Heart disease UCI. Click on that. You will get this heart disease UCI. Okay, because I know na the my experience that this is the UCI, the government data. Okay, and this is the most popular one in the field of heart disease. See, same age, gender, chest pain, resting blood pressure. And if you check what are they mean, just go to the column section and you will find age in years. Okay, gender, chest pain, like this. Okay, resting blood pressure, this cholesterol. Okay, fasting blood sugar, FBS mean rest, ECG resting. Oh, I don't know these all terms. Okay, thalage, maximum heart rate achieved. Okay, exchange means exercise induced angina. I don't know about this. Okay, I'm not doctor. ST, depression induced by exercise related to rest. I don't know about this. Just download it. Okay, just download it and see you will get heart disease here and paste it somewhere like in the desktop itself or any makeup folder, or you can do it. Let me know when you are done. Latecomers, you are missing many things. Well, let me know when you are done. Okay, just go to hard disk UCI and download the data set. Okay, I'm gonna wait for 2 minutes. So download the data set and you will get this kind of data set. Okay, first of all, let me know how many people are going to do their first project today. Like I'm gonna teach you a project with a machine learning algorithm. How many people it's like their first time for this project?
This will be my first project, I think.
It's
In
your
the field of machine learning.
okay. I will. Okay, okay. All right. Okay. So let me know when you are done, because now from like this Kaggle link, I'll just write Kaggle. Okay. See in the chat, meeting chat. Just download this. Okay. See this cats also docs is also there. It's a deep learning part, because through machine learning you can do image classification, but it's not gonna be good, because in deep learning there is a term called CNN that provides many features to do image classification, like max pooling, the and activation function and all, many things, max pooling, various filters. Okay, so done. Shall I move ahead? Upasna and Pooja.
1 minute.
Okay. Upasna and Pooja, go to this link which you just joined. Okay, go to this link and download this data set.
Yes, sir.
You two have missed some important stuffs like data science steps. So after this, watch the recording again, okay? Because that's very important. So
Yes.
okay,
तो वो लिंक हमारे में नहीं आ रहा है,
क्या नहीं हो रहा है?
लिंक नहीं आ रहा क्योंकि हमने अभी ज्वाइन किया तो
अच्छा,
हमारी
ओके
चैट
ओके,
में अभी से स्टार्ट हुआ.
here you go, here you go.
थैंक यू सो मच सर.
Done. Okay, I'm gonna wait for 1 more minute. Just download. Done na? All right. Okay, so let's move forward. See, open your Jupyter. Okay, so see how many machine learning algorithms are there. As I said, you can use machine learning or deep learning also. Okay, neural network basically. But let's stick with machine learning algorithms. Okay, don't go for neural networks basically. Right now means just stick with machine learning. See, there are most popular 8 machine learning algorithms are there. Okay, uh, linear regression, it's for regression. Okay, I told you regression means those who changes with respect to time. But is this gonna be changed with respect to time? No, of course not. Of course, result will not change. Okay, cats will not become dogs. Dogs will not become cats with respect to time. So that comes under classification. As I said, na yesterday, just revising you machine learning types. Just revising stuffs that there are supervised, unsupervised, and reinforcement for robots. In supervised, you have classification, dogs versus cats, classification. Regression, which changes with respect to time, weather, stock market, Bitcoin price, COVID-19 cases. Unsupervised, which doesn't have any labels. Okay. So we are doing right now classification project, classifying. Okay. So algorithm. Logistic regression is a part of classification. Its name is confusing. Okay, name is confusing. Its debate is always going on. Why it's a regression? Means why they have given regression name to confuse people. It's a classification algorithm. Okay, I'm again saying you can just write why. See, you will find many debates. Why logistic regression is called regression? Okay, so it's like many debates are going on in Quora. If it doesn't model, you can see. Okay, so don't get confused. So it's a classification algorithm. The name is confusing, but this is a regression, a linear regression. Okay, Decision tree can do both classification and regression also. KNN can do both classification and regression also. Random forest can do both classification and regression also. K means is for unsupervised learning, clustering. Okay, so you can find the information in the Google itself. Okay, so you don't need to by heart it. Okay, you can always search what's the best regression techniques. You will find linear regression. What's the best classification algorithms? You will find this. Okay, or regressions for both. Okay, or what are the those algorithms which can do classification regression? You will find this. Okay, so always you can Google it. Google is your best friend. Okay. So right now we are going to use, okay, first of all, let's import the data. Na? As I said, what are the data science steps? Okay, everyone done? Okay. See, data is there, data we got. Okay. So now, first of all, always what? Import libraries. Import libraries. Okay. Let's import to read the data. To read the data, we need pandas. Okay, there are some important libraries we always need. Okay, pandas, matplotlib for visualization. Okay, pandas to read data and to play with it. Okay, to play with it and to play with it. Play with it means and to play with it. Play with it means doing many things. Matplotlib and Seaborn and Plotly are various visualization techniques. You can do visualization using pandas also, because the pandas visualization are handled by matplotlib. Okay, so they all support each other, kind of thing. Okay, visualization tools. Okay, and sklearn or scikit-learn is basically for what? For machine learning. Okay, and you will not need much, I guess. If you need, I'll import. Okay, so see, so this is the comment. Okay, like I've done commenting. Import pandas. I have imported the pandas library. If you have not installed pandas, pip install in the Jupyter notebook. You can install itself by giving this explanation, so that you can tell Jupyter that this is a command. Okay, pip install pandas, or you can open anaconda prompt, not local cmd prompt. Okay, because Jupyter notebook belongs to anaconda environment, right? I told you yesterday there are two environments, local and anaconda. Okay, so local you can use command prompt when you are dealing with simple ideally or any other ideally. Jupyter runs on anaconda environment, so always use anaconda prompt. Then you can do here and pip install Jupyter. Okay, so here you don't need to give the exclamation mark. Okay, so just do this and just write here and run it. Requirement already satisfied, I've done. Okay, so and similarly you need to do for how to know, like okay, how to know what to write. Sometimes you need to write different things. Okay, so just always you can Google it. Okay, always you can Google it. Let's say you can always Google it. Pip inst how to install pandas using pip. Okay, Google is your best friend, I'm again telling. Okay, so many times we say na, like how coders remember their code. They don't remember their code, they just remember the logic. Like in data science steps, I know the logic, right? If data is missing, then what I need to do? I need to do handling. Either I can remove or either I can fill them. How to fill them? I can just Google it, right? Code is there, code is always available. You just need to know the logic, you just need to remember the logic. Okay, and then you can Google it. How to do missing values. Okay, or how to handle missing values. Code will be there. How to remove outliers, code will be there. Okay, so pip install pandas. So you can copy this, you can paste it here, and there go. Similarly, you can do pip install matplotlib. Okay, and similarly you can do for Seaborn. Okay, pip install seaborn. Just do this. Okay, then let's see. And so pip install matplotlib and do this too. Okay. Everyone done? Let me know.
Yeah.
Okay, done. Huh? Shall I move ahead? Anyone left? Anyone leaving behind? Okay, done. Okay, I'm assuming everyone done, so I'm going ahead. Okay. So see, let me do this. Okay. Pip install. Okay. I'm gonna remove this. So uh, let's read that data. PD dot sorry, import pandas as PD. This is alias. Alias means nickname, giving nickname. Okay. So because we need to use pandas many times, so that's giving nickname. Okay, that's all. PD dot. If you press tab, 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 there are two important buttons. Okay, let me just tell you. Two important buttons there are in the Jupyter notebook. Other IDs for other IDs they are different. Okay, for Jupyter it's different. Shift plus tab. Okay, so two important. First of all, press tab. Oh, first of all, I need to. I think I have not. I've imported now. So PD dot. Why I'm not getting anything? Sometimes it does happen. That's if I'm teaching someone. Yeah. See, there are many functions in pandas. Okay. Always read the documentation how to use these things. Okay. Always do this. Always. Where your pandas is basically. Where is your pandas? PD means pandas. Where your pandas is present? I told you yesterday in the site packages. But it's an Anaconda environment, so it will be present in C users in my computer. Thearo, Anaconda 3 in the library folder in the site packages. There is a pandas, and there is a file called init. So from here it is getting called. Okay, you can check. You can check. Okay, under your this you will get that file. Okay, so from here you are calling pandas. Okay, after installation, pip install, it is getting installed. Okay, so here it will get installed here. See, you just Thearo Anaconda 3 library site packages pandas here. Okay, so and if you write help or dir directory of pandas, you will get all the functions. Okay, all the functions you will get this. Not you don't need to use this. Okay, but other than that, there are other like this. So okay, so PD dot tab and what function we need to use this read CSV because it's a CSV file. If it's Excel, you need to call Excel or any other thing. Okay, like JSON and all SQL. Okay, pickle file CSV. There you go. And where it is right now, where it is, where I have saved, where you have saved, just do this. What? See, hard disk prediction. I think it's not. Oh, where is my file? Um, Python 37 data. Okay, it is available in this in my D drive hard disk prediction. It is here. So what I will do? I'll simply just pd.read. Now press Shift plus Tab. Okay, after writing here you can also press Shift plus Tab. Okay, you will get what you need to write. Tab button will show you functions. Shift plus Tab will show you parameters of that function. File path. First of all, you will need to give file path or buffer basically. Okay, so file path you need to give. Then other thing you can give. This is not that important right now. Okay, like skip rows and all. If any none values are there, you can skip it. Okay, so there are many parameters, but we just need to give file path. Okay, the first parameter here, and the others are by default. These are by default. This is by default. Okay, none is by default, but this is not by default. Is there any is equal to? No. Okay, this we need to go. We need to give. Others are by default. Separate is equals to this comma is by default. This is by default none. Okay. Read CSV file path, and where is my file path? Just copied, pasted this. Okay, this, and what is the file name under this heart dot csv. Okay, you can check the properties dot csv. Okay, so HERT dot CSV. Now one more thing, either see Python takes everything in the forward slash, so you either you can go for this and like this, okay, like this, but sometimes the path is very huge. I am showing you a technique, okay. Sometimes the path is very huge, so you don't want to edit this, right? So just put R here before inverted comma, single or double you can use. Just put R here, okay. So Python will reverse it by itself, okay. pd.read csv and import it, and here you go. Your same data, this data, okay, 6313, this data has been imported here. See, 303 rows is there. That's why after 4 it is like dot dot dot, and then directly 298, 299, 300, 301, 302. 303 rows means including 0 to 302. And 14 columns mean from 1 to 14. How many people are able to, like, how many people imported successfully? How many people imported successfully?
I sir.
Okay, done. Anyone left? I think I need to go ahead. Okay, I'm moving ahead. So just, acha, okay, one more thing. You need to store this in a variable, okay? So you can write any variable name, data frame or data set or heart or anything you need to write. Okay, data set equals to this is your data set. What we call basically a data frame. Okay, this is a basically a data frame. Okay, data frame. This is a single column is called series. The number of multiple number of columns are called data frame. This means data set is called data frame. Okay, and so data set has been imported. Okay, to shorten this I just need to write head function, so top 5 rows it will show data. Now see, from here after taking the data, what we need to do, where it is, okay, data machine learning or data science steps. Okay, what we need to do is, if I go here, data cleaning. Okay, see, business understanding means we need to do hard disease prediction. Data mining we done, means we took the data. Okay, data cleaning we are not doing because we have very cleaned the data. Okay, we have very cleaned the data. This is a ready-made most basic data. Iris flower classification, heart disease prediction, breast cancer prediction to liver, something like that, liver cancer or whatever, liver disease. It's one of the most basic data that beginners start. Okay, so that's why data is very cleaned. So we are not doing this. Then now we are going to do data exploration, including data visualization also. We have to do this. Data visualization is same. Okay, means data visualization comes under data exploration. I don't know why they have written apart. Okay, So after cleaning the data, we need to do data visualization also. And data exploration means we are exploring the data. Step is called exploratory data analysis. Okay. Now we are going to do EDA. Exploratory. I'm sorry for spellings. I'm not good at. Exploratory data analysis. Okay. So cell type, mark it down, and EDA we are going to do. Okay. So see, let's explore the data. Any question? While loading data, I'm getting Unicode error. How it's the most basic data you have downloaded from here, right? Unicode error. Are you writing like same? Are you writing read CSV and you are giving extension name? Super confusing because the most XLRD error you will get. Okay, read Excel or then how you can do? You can go for Unicode error. Show your show your code in the WhatsApp group na. Let's solve that right now. Take the pic and show in the send it in the okay. Done. What done? Okay, now it's done. Okay, all right. Give me 1 second. All right. So okay, let's explore the data. Exploration means we are just exploring like what is the data shape. Data dot shape. 303 rows, 14 columns. Okay. Data dot info. Data set dot info. Information of the data. This is where you will get null values. Information about null values. 303 rows is non-null. If there is let's say if there is 3 null rows, so you will get 300 non-null, means 300 non-null means out of 303, 300 is non-null, basically means 3 null values. D type is integer. This is integer. Okay, these columns are integer. This is float. Others are basically integers. Okay. Data set dot is null. Okay, you can directly check null values. Is null dot is null. False true, but like there are 303 rows, so is null dot sum function. Data set dot is null dot sum. See 000, no null values. This is very clean the data. We are exploring the data right now. Okay. No question. All right. Data is null. Okay. In this data set, see this data frame also has many functions, right? Just like PD, from pandas we have imported this data set, and this data set itself has many functions like data.info, data.is null. This fill now function will fill your null values. Okay. Is null, same. Okay. Info, data set dot describe. Now we are describing the data set. Describe. Here you go. Describing the data. Count means total number of rows, or for everyone is 303. Average age, mean average is 54, means out of 303 person, if on an average age is 54. Okay. See, minimum age is 29, maximum age is 77. 25% of the people are having 47 age. Okay. 55, 50% of the people are having 55. Okay, 75% are comes under 61. Maximum age is 77. Minimum all of that data set and minimum is 29. Gender, see here, gender average gender 0.68, which doesn't make any sense. So always remember that all thing will not make any sense. Okay, of course it's not gonna make any sense. Minimum age 0, sorry, minimum gender 0, maximum gender 1. But 1 is for male, 0 is for female. Okay, so is it making any sense? No. So everything will not make any sense. Okay, so don't get confused. And you can say for see for others. Okay, this column will not also make any sense, target and all others you can check, like resting blood pressure. Okay, average resting blood pressure 131, standard deviation 17, minimum 94, maximum 200, cholesterol 564 maximum, minimum cholesterol 126, and on an average 246. So that's how you are exploring the data. Okay, uh, let's visualize the data. Okay, we can do more exploration. Let's visualize the data. Data set dot from pandas itself. This is, of course, this is the part of panda. No? From pandas itself, you can do visualization. This visualization you do either you can call matplotlib, you can call seaborn, you can call plotly, or from pandas itself, because the backend of pandas, the visualization is done by matplotlib in pandas. Okay, so they both, like, help each other. Data set dot what you need to do, plot tab plot, you will see. Now shift plus tab, what you need to give here. Is there any parameter? See in the parameters, data, the data name, that is data set, x and y. Okay, and other parameters you can give, like kind, what kind of graph you need, bar, box, density, area, pie, scatter. Okay, and others are there which is right now not much use, this title and all you can give. Okay, dot plot, shift plus tab you have written, and then first of all data set. Okay, the data name means what you need to give, either sometimes parameters are given here, okay, to write, or if you go down you will find it, data, x and y you need to give, and a kind. Okay, so by default, if you don't give kind, by default it will plot the line graph. Okay, so all the documentation are given in the documentation, you just need to google it. Okay, x and y. So how to call x? From the data set you are calling x, let's say age, and we want to compare age with target. Okay, target, and uh, uh, series objects are mutable, they not. Oh, sorry. I've already given data set name now, so I don't need to give data set here again. Target is not a valid plot kind. Okay. So I think it can't plot a line graph. So BAR. Why it's having so much problem? And kind, KIND. So values for keyword argument kind. Not able to understand, like, what's data set dot plot already given x and y. Why it's having so much problem? Data, or I've already given, I think. So I think that's why. Guys, give me 1 minute now. I've done this project. So give me 1 minute. I just need to see something. to figure out something. Hmm. Dot haste. PLT dot bar from matplotlib. Yeah, let's call it directly from matplotlib. Hmm. Give me 1 second. So, okay, all right. I'm not gonna go for pandas. Just import one more thing called matplotlib. Okay, import matplotlib lib dot pyplot. That's how we call it as PLT. Just import this. Anybody? Okay. I'll see that I don't get that error. Basically, import matplotlib dot pyplot as PLT. Okay. This matplotlib and one more thing, call it cbon. Call cbon also as SNS. PLT SNS. I need to see about the pandas. Like why? Like I'm giving the right parameters, so I'm copy pasting these 2 lines. Okay, in the chat you can directly copy it. I need to check for the pandas. Like what wrong I'm doing. Hmm. Dataset dot bar. No, 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 no. So dot plot. Give me 1 second more. So that till then you import it and run that cell. Series each target. Yeah, now. I don't know what was the problem. Okay, so from pandas itself, from that data frame we have plotted. Okay, see this matplotlib is working. Okay, so see this. Any question from anywhere? No. Okay. This graph, don't get confused. See, it's simple to understand. Okay, it is like this. See, 0. See, in the x-axis we want age, in the y-axis we want target. So from age, like see in the data set, those who are not having heart disease from 35 almost to 75, they are not having heart disease, or 77, the maximum age. Okay, and those person who are having heart disease belongs from 29. Okay, in the according to the heart disease. Okay, till 75 almost. Okay, to remove this kind of lines now, sometimes so just write plt dot show, but first of all you need to import these two. Okay, matplotlib and cbon. Okay, so for like this plt, that is matplotlib dot show, so it will remove this. So here you go. Okay, you can plot many kind of visualization like plt dot plot. What you need to do, like say x is equals to or directly you can write what else mm, let's say age with this resting blood pressure. Let's compare now. So we are doing exploratory data analysis right now. So age with this. See, this is line graph. We see this is line graph. Okay, by default. So it's like very bad, right? So just give the that which what you want scatter. Now it's better. So see, resting blood pressure. Those person who is having that 29 is the minimum age is 29. Now we saw in that statistical analysis This is what we call like statistical analysis also. Okay, we are looking at statistics. Minimum is 29, maximum is 27. Okay, so see, that person who is having 29 age is having almost this 130 resting blood pressure. Okay, according to the data set. So data set is spreaded like this. This is very non-linear. Okay, this is very scattered. You can similarly go for various kind of things. Okay, one last is, see, if you plot same thing now with matplotlib, they will plot same. Okay, let's say plt dot scatter. Okay, from matplotlib scatter and shift plus tab, x and y you need to give. So from data set, just syntax is different. Okay, so for matplotlib you need to write plt dot scatter kind of thing. Okay, from data set you want age, and for y from data set you want test bps. See, graphs are same. Okay, so they both are same. To remove this line, plt dot show, there you go. Okay, like this. Similarly, SNS, just some basic syntax different. SNS dot scatter plot is there. Okay, like instead of scatter, it's like scatter plot. They have given the name, and x and y you need to write. You can just copy paste same. But Seaborn is more beautiful. Okay, it's little more beautiful. And to remove this line, you can again use matplotlib, that plt dot show. Even though it's a plot of Seaborn, but you can use matplotlib dot show. So that's how you can do visualization. Till now, anyone having any doubt? Let me know. Age and so, yes, you can take anything. You can take anything, Ashika. Till now, anyone having doubt? Let me know. No understood till now? Okay. Please write, everyone. All the 20 people, please at least write some. 2 no I got, and any doubt till now? No doubt. Okay. 3 no. Okay. So if there is any doubt, then ask me. Okay. Just don't. You should not like waste this opportunity. So, sir, can we do this for all VS Code? Yes, you can. But see, graphical, see, Jupyter is good for reporting, right? You can show this to anyone. But if you do this in any other IDE, na, it's like, no, it's not gonna see much well. Okay, that's why we prefer Jupyter for data science. And to turn this into a machine learning application, like end to end. Okay, then after doing this reporting, you can download this file. Oh, sorry, you can download this. Download as either IPYMB notebook for Jupyter, or you can also go for Python.py, and you can open this using PyCharm or VS Code, and you can do your you can attach your website with this. That's a different thing. Okay, so all right. So see, one more thing, like sans dot bar plot, and let's do for what she said, we age and slope. Okay, so let's do for age and slope. Age, slope. Oops, yeah, from data set we need to give. After this, I'll give you a link of my own video which I have done hard disease prediction. Not looking much well. So to solve this kind of problem, now to solve this kind of problem, you can just Google. What Google? See how to increase the width. Okay, or even SNS also provides. I think No. RC param something is like this. I've used, I think. No. I have used in Abbey Prophet, I guess. Yeah. Just write this. Wait, let me try myself. Yeah, your graph is little bigger, but we don't want this much bigger. 15 is enough. Wait, guys, let me first try. Okay, you can play with these parameters. Okay, see, just write plt dot rc params. Okay, I'm copy pasting this in the chat. Just copy this code. Okay, those who are watching later, you can just pause the video. And here you go. Well, it's still very large. But you can play with the parameters always. Okay, 10 and the width we want 12. Let's check. It's now very huge. Yeah, now it's little better. 10, 12. Okay, so exploratory data analysis is done. Okay, it's done. I think it's 10 is for width. I think this one, if I'm not wrong, because that is increasing 12 by 12. Yeah, okay. So you can do more exploratory data analysis. Okay, I'm just giving you some basic idea, head start training. Okay, so data exploration with data visualization is done. They both are done together, basically. Feature engineering. Now let's come to this. It's like this is a very cleaned data. Okay, and even after training only we can get sometimes that yes, this feature is important. There are various kind of techniques. Okay, which I don't want to talk about. So now see, EDA is done. Let's do what the before this one more thing comes now, exploratory data analysis or data in the preparation processing. EDA is also like, it's a part of data preparation, because even after only exploring the data we can get the main thing. Okay, like what to do, what not to do. Now one thing we need to do is normalization. Okay, we don't have missing values. We don't need to do data manipulation, data blending. Feature generation we don't need to do. We have enough features, enough columns. We don't need to reduce the dimensionality because our data set is not huge. Okay, feature selection we don't need to do because every feature is important. This is a ready-made data. Outlier, there is no outlier. Can anybody tell me what is outlier? Can anybody tell me what is outlier? Don't Google, na? Don't Google right now. Can I just like what is outlier? No, not random sample. No.
Maybe that the thing that changes far from the boundaries or something like that.
You can say. See, sometimes now let's see. Our data set is like this. From or let's say if I go into describe function. Okay. Yeah. Our age is like, from 29 to 77. Okay. if most of our data is like this, okay, like say, let's do one more thing called data set dot distribution. Oops. What's the dist dot, I think it's something like that, if I'm not wrong. Dist dot, nope, sorry, data set dot or it is from Seaborn, I guess. SNS dot dist prod here, distribution of what is a? It is a, is the data set or all? Series or list. Okay, data set H. And to remove this, you can use plt.show. Okay, see, our age is distributed like this from 20 to from here, like almost 77, like this. Okay, so from 29, okay, from 29, not 20, so 29 to this 77. Okay, and till like your boundaries are like this. Okay, or yeah, like this. Or you can check the outliers using scatter plot also. SNS dot, I'm calling from the scatter SNS data set dot, sorry, data set H. Oh, X and Y we both need to give. Oh, okay, let's give it target, based on target. See, only after EDA you can get if you have outliers or not. Okay, see, this is like target. Let me make this small, little small. Only after EDA you can get any idea that you have outliers or not. Okay, or okay, see, according to our data we have like 29 till 77. Okay, this is not hard disk, this is hard disk. What if there is a dot, there is a data which is very far from the all the data on the average? Like if data is somewhere like 10, age 10 or age 150, then what you will do? Your model will get confused. What you need to do, right? Your model will get confused basically. Okay, because it's like on an average our age is 54. Okay, then suddenly your model will see someone age 200, someone is having age 200, your model will get confused, like it's far from, very far from average. So you need to remove that. Okay, you need to remove that. That is called outlier. So we don't have outliers. Okay, we don't have anything, we just need to do normalization. What is normalization? Can anybody tell me what is normalization? See, we don't have, I took very clean the data. We don't need to do anything like this. We don't need to do we don't have missing values. We don't need to feature generation. We don't need to reduce the features. We don't need to select the features, because like right now all the features are important. Features means, I said na, these columns. Okay, these columns are called features. Outlier we don't have. Parsing, it's nothing. Okay, like right now we just need to do normalization. Okay, after doing exploratory data analysis we got that nothing is there, nothing we need to do, only normalization. Can anybody tell me what is normalization? Last part, last thing before model training we are going to do.
A technique used for data preparation, I thought.
Oh, it's a technique, but what is normalization technique? Na, what is that basically? It's a technique, I know.
Desorting. Okay, the data. Okay. Uh, Distorting means, I thought.
No.
Okay.
Nice try, nice try. Anybody? Normalization, just think about that.
Since now the values are very varied, maybe bringing them close together or something like that.
You saw that Google, na? You saw in the Google, na?
Nah, I
Okay.
don't know that.
Uh,
But maybe
okay.
it
Okay.
is right. I don't know.
Okay. Okay. All right. 632. It's like. Okay. Okay. Yeah, you're right. See what's the case now? Right now is if you just look at our data set, we need to. We are not going to change their data. We are just going to scale down them like in a particular scale, like normalization means between 0 to 1. Okay, there is another thing called standardization. Either we do standardization, we do normalization. Okay, so just understand that, see, difference between 1 and 233 is very huge now. Okay, so it's like our model will get confused. Okay, so we need to scale down them, okay, into a similar level. Their data will not change. Okay, just the values, just the numbers will change, so that because model will need to get converged. Converged mean, of course, it will need to reach the end point, right? So every value should be same scale. Okay, so you can Google always we are what's the spelling? I'm very bad at spelling. Various data normalization techniques. Here you go. Always Google it. Okay, you will get standardization, normalization. Okay, decimal scaling, min max, Z score means no standardization. This one. Okay, many things. Okay, how to standardize the data means same. So what is standardization? What is normalization? It's like let me explain. See, decimal scaling, then you have min max normalization. Okay, and we have Z score normalization means standardization. We saw standard deviation. In that, mean is 0 and standard deviation is 1. After applying this formula, okay, the average mean of our data set will be 0, okay, and standard deviation will be 1. Right now you can see the standard deviation is, the mean is like 54, this and this and this. Standard deviation is 9, 0, 1, 17. So after scaling down in a particular level, their mean will become 0, standard deviation will be 1. What is min max scalar? All the values will be between 0 and 1. Okay, so it's like this 63 and 1 will be like 63 might become 0.63, 1 will become might 1.0, 37 might become 0.37. Okay, it's like this. Various normalization techniques. You can use either any one, or you can use all, and all means you can use different to compare, in which you are getting better results. Okay, this is the notebook which I will give you. Like, I have done many good things here. Okay, but data pre-processing, under that what I did, okay, I did standard scalar here. Give me 1 second, guys. Even I need to remember. Okay, hard dot drop. Okay. Here we need to do standard scalar, I think. Give me 1 second. No? Yeah, I have done standard scalar here. Okay. So see one more thing. Like suddenly I just remember. Okay, see, in all it's not necessary that you do standard scalar or normalization in every algorithm. Okay, like some you will get experience, then you will just understand. Okay, some algorithm will not require normalization. Okay, some will require. Okay, but okay, let's do like no loss in that. So see, now we need to do standard scaling. Okay, we are going to do standard scaling or normalization technique. Okay, so let me write here. All right, normalization technique. I'm sorry for my spellings. So see, now you have data set. Okay, the data set. Sorry, it's d, small d. Till now, anyone any doubt? I hope no. Okay, we have this data set. See, let's first of all split the data. Split the data. Splitting the data means for classification we need two things. This, okay, the x and the y, the independent and the dependent. Okay, so before standard scalar, I will move this down. We are doing splitting the data. Okay, splitting the data. Okay, so one more thing, we don't need to do a normalization in dependent variable. We don't need to do. Okay, like you can always Google, do we need to do normalization in a target variable? Then you will find yes, you sometimes they may say yes, you need to do. Okay, in some they will say no. So what you will do, you will do experiments. You will do experiments that what if you don't normalize your this target variable, will you get good accuracy? You will compare that, and if you don't get good accuracy, normalize this, then you will get. Okay, so always experiment and learn. Okay, no question. Okay, so let's split the data. This is your data set head. So for splitting the data, what we need to call, from sklearn, from that machine learning library, it provides many things. From sklearn model selection. From means from here we are calling train test split. Write this down. Okay, from sklearn models, this is all documentation is present. Okay, sklearn documentation, or you can directly write how to, as I said, Google is your best friend, how to split and train test and Python. So you will get this, or various website will tell you. Okay, train test split, see like explaining data and all. If you just go to documentation scikit-learn.org, they have shown how to do this. See, extend y train this train test split. Okay, by importing this. Okay, so split. So what and how to do? First x train, x test, y train, y test. I'll explain you. Okay, don't worry. So into 4 part we need to divide. Okay, the 4 part is, the first is training, and see this is, see data set. How do we compare that our model did well? Training and testing, right? Training and testing. These 303 rows will be divided into 2 parts, training and testing. Okay, and in that x train means the features, the independent one, and y train is the target. Y train is the target, means 70%, let's say 70% will go for training, 30% will go for testing. Then we can compare now that whatever we trained, is it after testing in those 30% data, is our accuracy is getting good or not? I'll explain you everything, okay, don't worry. Then X test means those 30% of this X, okay, and one side it will be Y test. This is like 30% or 20% you can take, 80-20 ratio you can take, okay. Any question? No question. Okay, so how to split? X train, write X train, X test, okay, Y train, Y test, okay. Sometimes people write X train, Y train in the smaller, everything in the smaller, it's up to you. Then call this train test split method, shift plus tab, and you will see the parameters you need to give. This test size arrays you need to give, okay, like I'll tell you. Train side random state, okay. This. So you need to give two things. What? No, only you just need to give data set. X and Y. Oops, I forgot. I forgot one thing. I'm sorry. I forgot one thing. What? Oh, I'm sorry. One thing I forgot. What? First of all, let's go with X. Okay. X is this, na? X is this, and Y is this. Okay. So first, we need to give X and Y. Okay. This is X. So X data set dot, what, data set dot drop, or how do we write data set dot? Okay. Do I need to give it like this, or should I go for like this? I hope I don't confuse them. Okay, leave it. See, we need till here. Okay, we need till here, and this is our Y. Okay, so Y we will give, let's say, data set. Oops. Data set, and this is target. Okay, and X, the remaining is X. Okay, the features. So data set dot drop, we will drop, what we will drop? The target one. Okay, the target, from where X is equals to 1. X is equals to 1 means from columns. Always remember, X is equals to 0 means rows, but target is not in rows, right? Target is in columns. So what we want the full data set, but drop the target column from the axis one, means the from the columns. Okay, so here you go. So now if you look at X, here you go till THAL. Okay, X, full rows are there, 303 head, and this is your Y dot Y. See the targets from 1 and 0 to 303. Okay, now you just need to split it. Okay, now X and Y, we have X and Y. Okay, and now we have X and Y, right? So those X and Y we will split into training, the 70% of X with the features and the what, its labels Y. Testing 30%, the 30% of X and the 30% of Y. Okay, so data set, not the, we just need to write X and Y.
So there are questions in the chat.
What is X train, Y train? Okay. So what is X train, Y train? Just, it's simple. See, we divided our data into X and Y, right? X is the features, independent variables. Y is the target. Okay, means after only this features, we can say na, like this, we have hard disease or not. So X train and Y train is simple. That okay. Like see, we need to divide our data into training and testing. We need to divide into training and testing. 70% will go into training. Then after training, we will do testing on the 30% data. And if testing is successful, then it will show the accuracy. Okay, that we got good result. Then to train and test, okay, we need to divide X and Y, right? So 70% of the data of X with their labels, Y's labels, right? Y's labels. This is the features, this is the labels, the target. So 70% of X with its label will go for the training. 30% of the X, okay, what we call X test, we will call it, okay, with its labels, Y will go for the testing. So we are dividing X and Y here, okay, we are giving 70% of X to X train, 30% of the X, it will, this function will do automatically, okay, 70 and 30, like I'll tell you, means this function will do automatically, this here and here, okay. So X, we will go here, the 30% will go here, like we can define our own test size, okay, like what's the default one? What's the default one is, oops, what's the default one? The size is, default one is 0.25, okay, like the default means 25%, okay. You can test size, test oops, test size is equals to 0.3. So oops, sorry, so it's like 70% of the X will go to here, 30% will go to X here. So 70% of the X will go to here with its labels Y, what we call Y train, okay, and 30% of the X will go here with its label, what we call Y test, okay. Now you got it? Got it? Anyone having any doubt? Okay, is everyone got it till here?
Yeah.
What? Got it, okay. No problem now. Oh, I got 3 got it. Anyone else, like just write it down. Huh? There are 18 people, just write it down, everyone. Got it? Okay, got it. Very good. Thank God. So just run this and then, okay, one more thing is there, random state. What is random state? In the random state, you can give any number. See, randomly you want to split the data, right? Random state. Randomly you want to split the data. Means these 303 rows will be splitted on the training and testing randomly. So you can give anything. If you keep it none, every time, see, if I just do X train. See, in the X train, first row is 267, then this is 107, 101, 32, randomly 212 rows. Out of 303, 70% means 212 is 70% of 303. Okay, this is X train, and with its labels, Y train, how much? 212. Okay, see, 267, 291, 107, same. Okay, 267, 291, 107. Okay, it is labels. Okay, so but every time if you run this, every time, so your data will change. It's now 267, so now it's 239. So just do one thing, you can give any integer here, to match with my data. Now just give 101, just give 101, and every time when you will run this, you will get same. Every time you will run this, you will get same. See, 285, 297, every time it's same. Y train also, in X test and Y test also. X test dot, let me just write, not hat, total shape is 91 rows, mean the 30% of 303, and y test, the labels 221 889. Okay, 221 889. Okay, now what you say, is anybody is getting a question like if it is randomly distributing, okay, then how by giving 101 we all will get same result? Is anybody having question like this?
I was just able to ask that question.
Yeah. Anybody more question? Anybody is having question like this? And Chetan, yeah, same. And anybody more? Like if it is randomly distributing, now, then how by writing, like if you write 110, if we all write 110, it will show same result. How? Can anybody tell me? It is simple thing. Okay, it's simple one line answer, but it will confuse you a lot. But it's a simple answer. Anybody is getting same kind of question? 2% got. Chetan and one just spoke. Weber also, okay. So what if I tell you the answer is simple, that in mathematics, the random, okay. Right, we say na randomly it happened, but according to mathematics, the randomness is also match. The randomness behind everything is also match. There is a match behind everything. I said earlier that it will confuse you, but see, if you give 101, how it's gonna distribute randomly by putting this 101 value, it's gonna distribute randomly, something like this. I'm my even my wording is confusing you, but see, everything is like, see, there is no thing called random. Okay, there is no such thing called random. Maths are playing behind it. Okay, so sorry to confuse you, but that's the truth. So if you give 110, it will randomly distribute the data according to 110. Okay, so you can read more about it. So if you just give, see, now you will get same result like me in everything. Okay, same. So let's stick it to 101. Okay, splitting is done. Let's normalize it. Splitting is done. Let's normalize it. We just need to normalize x. We are not going to normalize y. That is y train and y test. As I said, you can do experiment. Okay. Like, see, in the dysentery I didn't normalize, but all right. X test. It is confusing me right now. Fit transform and okay. So just write. Oops. Just write from sklearn dot pre-processing. You want to import what? I need to see that in the Google, or I can check here. Standard scalar. I did. Or is it capital? That's why. Okay, standard scalar. It's in the capital. From sklearn dot pre-processing, you are importing standard scalar. Okay, do this. So this is a class basically. Okay, so how to call it? I'm just teaching you. Just do this standard scalar. Here you go. Now SC is standard scalar. Okay. Now X train. Let's give another name. X train standard scalar. I'm like, let's say call it X train STD. I'm giving. Okay, or you can give it X train itself. Okay, but just to keep it everything clean, I am separating the unscaled x train, okay, and after scaling it will become x train std, okay, and just giving different variable name so that if I need to undo it, I will not face any problem, okay. So sc dot fit, there is two things, fit transform. I will explain you, okay, don't worry. X train x test std equals to sc dot transform x test. Now what is this? What is this? Okay, sc dot fit transform is basically first learn the x train, the like, see, first it will learn. Fit transform means first it will learn the patterns of x train. You can say like how much it is like this, how to do transformation, okay. Then it will transform it, and then based on that it will transform x trace. Please never write fit here, because there is a term called data leakage. There is a term called data leakage. Data leakage. 1 minute, guys. 1 minute. Hello. Bro, I'm taking class. That Rajasthan, yeah, MS Pilani. Okay, लगाता हूँ. आधा घंटा, बस आधा घंटा. हाँ, okay. Hello. Yeah, sorry. Okay. So it was important call. Huh? Sorry. Yeah. So data leakage. There is a term called data leakage. It should not happen. Can anybody just tell me what is this? It should not happen. Can anybody tell me what is this?
No idea.
No idea, na? Okay. See, your model. See, your model should train the data in. Okay. Then for testing, this is the very new data for your model, right? If, like you give your exam, right? You learn from your textbook, then in exam most of your questions are very new, like it should be like this, right? Yeah, like all the question on mathematics are very new. So then only you can say now that you have studied so well that based on the new questions you are doing absolute fantastic job, right? But if you whatever you have studied, if it comes on the exam same questions, will you say that you are a genius student? No. Okay, so whatever you have studied, you should face new questions in the exam. Okay, but hello, can anybody hear me?
Yes, sir.
I don't know what happened, just like okay, all right. So this is the pre-processing thing now, before modeling. So your training model, training data should not know about testing data, okay? Your training data should not know about testing data, otherwise it will tell the model that these are the questions. Simple, okay? Like if it is still confusing you, that's okay, that's okay. You are doing this for the first time. Just go with the flow, okay? Just understand that first you need to import the data, then you need to do visualization, exploratory data analysis, then you need to do splitting the data, then you are normalizing it, the last pre-processing thing, then you're normalizing it, that's all, okay? Then after this you can Go ahead. Let's see. After normalization, it will look like this. See, like this. Earlier it was like 63, whatever 63, 233. Now see their values. So down, like almost in a one scale. 0, -2, 2 or 1. Okay. 1, 1, 0, -2, -1. Almost in a same scale, right? But earlier it was 1, then earlier it was 1, then 140, 233, 254. So it was very huge. Same X train STD. Same. Oh, sorry, it's X test. Okay. So your data pre-processing is completed. Okay. Anybody having any, see in standard scalar what happens? Mean becomes 0, average becomes 0. This is statistic part. Okay. After this session you learn about it. Otherwise you will get confused if I tell you everything. And standard deviation become 1. Earlier earlier your age was sorry, your mean was like this 0, then 131, 246. But now your whole data, for your whole data, your mean has become 0 and max and sorry, standard deviation has become 1. Okay. So as I said, there are various data normalization techniques. This is what we call standard deviation. We did this. You can do min max also. You can do this. This is decimal scaling also. Okay. So these are top 3. We did this Z score normalization. That is standard scalar, standard deviation. Okay. Now let's train our model. Anybody's any doubt? Any doubt? All clear? All clear? Before training, let me just ask how's the session going on, guys? Is it interesting? Like how's the session going? Just give your honest feedback. No, just give your honest feedback. Okay, even if it's a bad, then just tell me bad. Okay, I just need your honest feedback. Very interesting. Okay, please more feedback, please. Interesting, na? Okay. Let me drink water because now we are going for model training. I think I can just do one model training today. And the ones out there in the market, yes. Whew. See, one more thing, as only 2 hours 30 minutes is there, means tomorrow's 2 hours. So I think I can cover only because it's all available in Udemy, YouTube. Okay, so you can learn. It's like, as I said yesterday's class was super important. Okay, then whatever you are learning today, it's available in YouTube, Udemy. Okay, so it's all right. So I can just teach classification and regression. You can learn like rest of the things like unsupervised, because time is less, right? Time is less. That's why. Classification and regression you can learn. Like I'm teaching today classification. Tomorrow we will deal with one regression. Unsupervised learning, you can deal with it like unlabeled data. It's like all available in some Udemy or YouTube courses. It's all right. Okay. Yesterday class was very important because to understand where we are, and today class just to like know how what are the things are there. Okay. In YouTube, where I'll just give the link. Okay. All right. So um so let's start the machine learning model training. Okay. Model training, we say model training. What, like, which algorithm should we apply? One more thing. Many people get doubt, right? Which algorithm we need to apply, which algorithm we need to apply, and all and all and all, right? Many people get same kind of doubt, okay? But the answer is, for let's say classification, apply all kind of algorithms, including neural networks also. Then only you can get then only you can compare the accuracy, right? One more thing, okay, one more thing, let me write same, like same, okay. There are two rules. First, apply all algorithms means of particular ml type means whatever the type of project or thing. If it's a classification project, apply all kind of algorithms including neural networks also. And the second is, if one algorithm is performing well in a particular project, that doesn't mean it will perform good in the next project. Okay, what it means is, if one model is showing good results today, that doesn't mean it will show good results again. Okay, so funda is same, that if neural network is showing best result, it is possible that neural network will show poorest result in the next project. So every algorithm will perform different. Okay, their accuracy will differ with projects. So always apply all the algorithms, then decide. Okay, so will we get certificate of workshop? No, no, it's not a certification. Like, I don't have any like, okay, if it's provided from the college, then okay, because uh, I I don't have any kind of that thing to provide. If it, is college providing certificates? Because I have not told about anything about certificates. MSc Pilani, no, okay, then it's all right, not my headache. But see, one thing I need to tell, that you are joining, you deserve the certificate. Because many people just join for the damn certificate. I don't know what's the use of that. Okay, what's the use of that? Like, I don't have any this much kind of certificate, so I don't know. But I'm teaching, right? I'm teaching a college, so many people join for workshops. So basically, you all deserve certificates, and I will feel really bad that other people will get, those who will not even see even after the recording also. All right, not my headache. All right, let's start with logistic regression. 20 more minutes, okay? Like till 7:10 we will do. From sklearn dot how to call logistic regression? Like, this is a linear model, or in linear model it is there, or decision tree. Let's start with decision tree. Okay, let's start with decision tree. This one, what is decision tree? One more thing, guys. Receive any mails or anything? Okay, guys, can you do today, or is it too much for today? Too much. Say everyone. I can. Okay. One more answer. Then continue. Okay, then. Okay. Hmm. From sklearn dot tree import decision tree. Okay, like you can just Google. See, I told you now decision tree has classifier regressor also. Okay, you can just Google how to import decision tree. You will get. Okay, simple. What is decision tree? Let me just show you. Okay, decision tree. It's a very simple algorithm. Very simple. Okay. Uh, See, it's simple. What's the weather? Like it's a decision. Okay, like if it's a sunny, okay, then what's the time? If you have less amount of time, then go with the bus. If you have more amount of time, more than 30 minutes, then you can walk. If you're hungry, okay, if you're hungry, or if it's the weather is cloudy, let's say if it's a sunny, then time. If it's a cloudy, and if it's a cloudy, if you're hungry, I know it's not making much sense. Okay, like if it's cloudy and hungry, and why not time? But just understand. Okay, if you're hungry, then go with the walk. No, then go with the bus. Okay, it should be other way down, right? If it's raining, then go with the bus. It's simple. It's like making branches. See, it's making branches, right? It's making branches. Okay, so what it will do? Uh, See, hawk, pigeon, dolphin, bear. How to know which animal is that? If it had features or feature, I don't know what it is pronounced. Yes, true. Then can it fly? Yes, it can fly. Then it is hawk. If it can't fly, then it's a penguin. Has features? False. Means it don't have features or feathers. I don't know what it calls. If it has fins, I don't know what is fins. If it has fins, then it's a dolphin. No, then it is a bear. Same, it will make decision tree by itself. You don't need to make. Okay, you just import it. That's all. 2 lines of code. Question. Okay, 2 lines of code. Okay, what it will divide this, like it will say let's say where it is. Okay, let's say it's a label, right? So it will just analyze the data. If this pattern comes, okay, or let's say where is my x train. If this pattern comes, okay, let's say if this pattern comes, then you have, let's say first two is 0 0, no, first two is 0 0 in the x train and y train. So if this pattern comes, it will make a decision tree. Okay, if age is 46, then another branch, gender, then another branch of tree 0, another branch 140, another branch 301 11. Then you don't have hard disease. If you have this age or this and that, then you have heart disease. Okay, that's all. It will make it by itself. Okay, just 2 lines of code. Everyone understood decision tree? It's simple as hell. Okay, it's very simple. One of the most simple thing. Everybody understood? Write it down. Yes, okay, it's simple. Okay, now you just need to, this is a class, right? You just need to, let's say dt, you have given name, decision tree classifier, just you have now imported. This is your decision tree classifier dt. dt dot fit, here you don't need to transform anything. Okay, you really don't need to transform it. dt dot fit, 2 lines of code. You have just imported this, you have given a variable name, okay, decision tree classifier, and now dt dot fit, what you need to fit, x train, x basically with its labels, y train. Same technique will go for every damn algorithm. Apart from neural network, it's different. Okay, but same thing will happen with knn also. Knn.fit, logistic regression.fit, linear regression.fit, svm.fit, add a bush.fit, x bush.fit. Same, you are fitting your model. Just press shift plus enter or run. Oh, it's a capital Y. Training has done. Training has done this part. Training has done. This fit will do the training. Okay, this fit will do the training. Now we just need to dt dot. Now we just need to, what we need to do? We need to predict. We need to predict on test data. Okay, we divided into 4 sections, right? X train, Y train. We did for training, right? We did for training. Okay, now we will use X test data to test, and then we will compare the result with the actual one. I'll show you how. Okay, dot predict on the X test. See that those 30%. What was the X test? Basically, this was the X test. Okay, this was the X test. Means this is the unseen data. Your model is seeing this for the first time. Your model has done its training, X train and Y train. Okay, your model has done the training for the X train data. Now, with its labels, right? Your model has understood that, you know, whatever the features are, it is their labels. Now, your model is seeing this data for the first time. Okay, so your model will see this pattern, and your model have understood that your age, if your age is somewhere between these, your gender is 1, your chest pain is 0, or your chest BP is somewhere between these, then your model have learned that you might be having heart disease or not. And your model has, after doing prediction, your model is saying that for the first one it is 0. First one means for this one. For the 8, this one, your model is saying that you have heart disease. For the third one, for the fourth one, for the fifth one. How to know this is correct, or how to know the accuracy score? Okay, our model has trained and it has did prediction on the test data. Now let's compare the result of test data. Let's compare the result of test data with the actual data. Okay, that's how we do. First, the 4 things, right? So the first 2 we do for the training, like of course the X train, the features with its labels. We teach our model that if this patterns comes, then this is the label. If that patterns come, then this is the label. If that patterns come, then this is the labels. Then we do testing on the unseen data, the X test. Okay, and then like our model is seeing this for the first time. Now it will predict that whatever I have understood from the training, according to it, you don't have heart disease. Okay, now let's compare with the actual data. For the X test, what was the actual data? What was the actual data in the Y test? It was 0. See the 221. Okay, it was 0 and 221. Okay, this one 221, and our prediction, the model has predicted that yes, you don't have heart disease. This one is correct. This one is correct. This 3, 8, 89, 111, 111. Correct. Yes, our model is doing fine. It has predicted that yes, you don't have heart disease. You might not be having heart disease because whatever I have understood, according to that pattern, you don't have heart disease, or you have heart disease for 3. Then 0. Then 0. Yes, it is same as actual data, but let's come. But of course, if you have millions of rows, you are not going to compare each line, right? So there is a code to compare everything and to get the percentage. Okay, let's say y, sometimes you will see y predict written. This is the prediction, y predict, and we're gonna compare this with actual data. Okay, so y predict in the actual data. How to compare? We have one more thing, one more code. What? From sklearn dot model selection. Oh, sorry, matrix. Of course, we are seeing the matrix accuracy score. So accuracy score, two things we need to give: y true and y prediction. Y true means the actual data, the prediction one. Y test, the actual one. Okay, and the predicted one, y pred. 82%. 82% is the score. There are various matrices, like if you just search now, then you have precision score, you have recall, you have F1. There are various matrices. Let's just talk about one right now. Accuracy score is 82. So can anybody tell me, unmute everyone yourself, and can anybody tell me, is 82 good or bad? 82%. Okay, it's like 82%. Basically, if you just like it's written 0.82 means 82%. So what we did, we trained our model. So first of all, we did exploratory data analysis after importing. Then we splitted the data into X and Y test. Then we did splitted with X and Y test, Y and Y test. Then we do normalization. Okay, so that to make it in a same scale. Then we did training. Same. Just we call. You can call everything same. Like this, from sklearn dot something something import logistic regression. Then you lg is equals to this. Then lg is equals to fit. Then you're gonna compare same. Dot predict like this. Your model training is done. Prediction.
Sir, I just now saw that when I done different times, then the accuracy gets different.
It's all right. It's all right. Of course, our accuracy will differ, right? Only the data will be same. On the random state na we did na, only the data will be same. Okay, only the data will be same. But of course, the model training, it doesn't depend on my machine or your machine. Is 82 accuracy good? Can anybody tell me how to know is 82 accuracy good? How to know, right? How to know? Like this is a medical terms. Okay, this is a medical term. So if you say like 82% I am sure that you have heart disease, or 82% I am sure you don't have heart disease, is it good? Is it really good?
In medical terms, I think it must be 90%.
It should be 100%. It should be 99 at least. Okay, even if you're building self-driving car. So if you're 99%, if your car is 99% sure that front of the car is a human, is it good or bad? That your car is thinking that 99% I'm sure that front of me is a human. Is it good or bad? Self-driving car I'm talking about.
It is good.
No, it is very bad. Because if your self-driving car is thinking 99% also, what if 1%? What about that? It will cost a human life. Okay, so that thing is, it depends on the context. Okay, it depends and on the domain. In psychology, even 40% is good, because of course you can't think, na? Like you can't understand what the other person is thinking. So if 50% you guessed it right, then it's good. 50% is good there. So it depends on the domain. Accuracy good, okay. So all right. And as I said that if you apply other ML algorithms, then only you can compare. You first please don't say that I will apply this because previously I got good result with decision tree. No, 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 no. It will happen sometime that your decision tree will not perform better. It will perform very poor in another project. So always use all the algorithms. Okay, always use all the algorithms, then compare the results for every damn result, every damn thing. See, model evolution. We did data preparation, we did model training. We evaluated the model that our accuracy is this much. There are other matrices like ROC curve, cross validation, precision, accuracy, R1 or F1 score. Okay, 82% we didn't got satisfied, so they can do optimization. I'm not going to do that much, okay, like it's a little different topic. Like we can optimize the parameters. See, decision tree parameters, if you just see decision tree classifier, okay, 5 more minutes, decision tree classifier. See, these are the parameters by default. What if you change the parameters minimum sample split Siemens sample leaf? After it's a tree, right? So it will be having leaf. Okay. What if you change to 10? So that we call hyper tuning. Hyper or tuning optimization, model optimization that we say. Okay, we train it for the different parameters. Same model. We train for different parameters, parameter tuning, parameter optimization. Okay. Then your model accuracy will get differ. Okay, it will vary. So see the amount of time it will take to apply 5 different machine learning algorithms with hyper tuning. So it's like, you know, it will cost you like whole single day, okay, to do training, like applying 5 to 6 to 7 machine learning algorithms with hyper tuning, means to tune every parameter, to change every parameter and train. You don't need to do it manually. There is a coding for it. You can just search how to do model optimization, optimization. Spelling is model optimization. Its documentation is given. Okay. Coursera model optimization using sklearn or machine learning or model optimization. It's better. See, it's given. Okay. Okay, parameter grid, sometimes simple. So I'll give you some video links, you can say. So your project is done. We will do 2 to 3, like one more algorithm tomorrow is using same project. Okay. So you need to import the data. Then what you need to do? Okay, you need to import the data. Then you need to do explorative data analysis. Then you need to split the data, training testing. Then you need to standardize it, normalize it, and then model training. Then you can do hyper tuning, and then after this you can deploy it. If you get good accuracy, you can deploy that model of that particular algorithm into your website, and if anybody enters their data, like their age is this, their gender is it will guess and predict that yes, you might be having heart disease. Okay, your project is done. Is there any doubt? No? Then let me know how was the session. If there any doubt, then let me know. Otherwise, let me know also how was the session. If any question is there, you can unmute yourself. Okay, one great. More feedback, please. How was the session? Amazing, very informative. Okay. Okay. One more feedback, please. Then tata, goodbye. See you tomorrow. Pretty good, no? Okay, then. Good to know. All right, then. See you tomorrow. Okay. Okay, then. Bye bye, everyone. It's not hard, I guess, after today's workshop. Oh, that's the best compliment I can get, because to make everything easy, to make anything easy, it's like getting good. It's the best compliment I can get. Okay, all right. See you tomorrow. Take care. Okay. Now rest. Go for your lunch and all. Rest. Okay. Bye bye. Take care.